Hey everyone, good morning, good afternoon, good evening, wherever you are in the world, and welcome to week 2 of our machine learning for beginners. Now, this is a reactor series where we work through some great machine learning content, but we want you to be involved too. We want to get your questions, answer your questions, get your thoughts, and just have a conversation with you in the chat. So please, please, please leverage the chat as much as possible, but we do ask that you follow our code of conduct, and we'll get that pinned in the chat right away. Basically, don't be a jerk, be nice, or we'll kick you out of all Microsoft events. So with that, welcome to week 2 of machine learning for beginners. Once again, I'm super excited to be joined by the amazing Bea Stollnitz, who knows a billion times more things than I do. So Bea, say hello, introduce yourself.
Hello, everybody. My name is Bea Stollnitz, and I'm an advocate on the AI/ML team at Microsoft, and I'm here to answer your AI questions. So please ask questions.
Awesome, great. Glad to have you here, Bea. Got a few folks diving in the chat already, but yeah, please jump in the chat, say hello, let us know where in the world you are, and whether you came to our earlier sessions, and whether you've watched the videos for this week. So the structure of this is Monday we drop some videos, and then Thursday we're here to kind of walk through the videos, Friday answer questions. And I guess we also have to start with an apology. Last week we had this many questions and only this much time to do it. So I think if we missed any of your questions from last week, please drop them in the chat. But yeah, welcome. So Kevin came to one of our open source boot camps and now writing docs for 3 projects. Woo! Go Kevin. So yeah, if you live in the Seattle, Redmond area, where I live, and Bea lives the other side in Seattle. If you live in this area, then every few months I run a hands-on open source boot camp. Runs on a weekend, Saturday and Sunday, 2 days. We cover Git, GitHub, open source, free food, free lunch, free breakfast. Get to network with people and learn how to collaborate on code. It's a great way for everyone to learn open source. And yeah, Kevin came to one of our events. And yeah, Kevin is now writing docs for 3 projects and making open source contributions. And we love that because it's a great way to boost your profile, get to know people, make great contributions, and have fun. So welcome, Kevin. Glad to have you here. And Kevin's from Tacoma, which is local to us. Hence why they're able to come to our event, just down near the airport. So welcome. DB from New York, hello, welcome. Quinn Saab is back again. Glad to have you back with us. Awesome. And just for you as well, back in from Baltimore. Glad to have you with us. Aldo Garcia from the Florida, the other coast. Glad to have you back. Dariush from California. Marek from Poland. Yes, I did watch the videos. Brilliant. Good to know. And Quinn
He's so prepared. Yep. He's going to be so prepared for this.
This is what we want. We want folks to be prepared here. And Quinn Sab says, watch the video playlist and halfway through CS50 Python course. This is the Harvard Python course we talked about a bit last week. So great to have you here. Awesome. Oh, and Andres Guzman, hello from Mexico, also doing CS50.
Nice.
And now interested in ML. So
perfect.
Yeah, we were talking about this last week, weren't we, Bea? That a lot of ML is Python. So having that, that Python course under your belt is a good thing, isn't it?
Yeah, I think it's like a prerequisite. It's even more of a prerequisite than the math foundations, I would say, is just being very comfortable with Python.
Yeah, because a lot of it is we are calling into libraries, aren't we? We are using libraries built in Python. So we don't necessarily have to know how they work under the hood. It helps, and that's kind of, I guess, what we're trying to cover here today. But at the very least, you should better know how to call the libraries.
Yep.
Cool Bro said, had some issues adding Z shell to VS Code. Okay. What issues are you having? Because are you in codespaces? Are you just running locally? What issues?
I actually I have a blog post about that. Let's see if I can find it.
Oh, thank you, Bea.
Let's see if I can find it.
Yeah, there you go. We have the answer. You came to the right place, Cool Bros. So yeah, we'll get you the answer. Marek says, oh, sorry, Bea.
Actually, I maybe have 2 blog posts that touch on the topic. So let me. You continue. I'll let you know.
Oh, brilliant! Thank you. So Marek from Oakland. I guess that's Oakland, California. I'm guessing. Glad to have you here. And Kevin says, I love that most schools are moving from Java, C++ to teaching Python. Yes, and no. I mean, I have thoughts on all the things. I mean, Python is a great language to learn. It's a great language for beginners, and it does mix a lot of object orientation and imperative programming. I think it's good to learn a wide range, especially at university. Things like C++, I think, is a good language to at least be aware of because it gives you some understanding of memory access and a lot of strong object-oriented programming concepts, but it's not used that much. So in terms of getting a job, doing one course in C++ is probably a good thing because it gives you some good foundations, but you won't necessarily get a job in C++ compared to get a job in Python. There's this many C++ jobs, this many Python jobs. You agree,
Yeah,
Bea?
I do agree with that. I think especially, I think with Java, you get the object-oriented aspect of it that you don't get with Python. And with C++, you get both the object-oriented aspect and the memory management aspect. And you may think, like, why do I need to know those things? These days it's all Python and JavaScript or TypeScript or whatever. And it's true, but like, I do feel like the more you know, the better you are when you're using languages that are more limited because you're thinking about those things, right? And you may not have to manage your memory, but you won't write code that unnecessarily uses a lot of memory because you're aware of it. You're aware of how the language manages that memory, right? So that's just one example. So in even Python, you can write Python in an object-oriented way. I often do. And so even though it's not required and it's not used all the time, it's certainly the right thing to do for certain scenarios. So I think that having that foundation is important.
Yeah, just thinking, especially like machine learning, the models are big, aren't they? So, it's being aware of memory is a good thing. Be able to think, okay, my code is not the most memory efficient because if you're trying to load some of the large models, we're talking about OpenAI is kind of the new hotness, and those models are how many gigabytes in size, hundreds of gigabytes in size. There's not like you can just write some bad code that creates lots of copies of the model and tries to run it. You have to be efficient because your hardware will not be able to cope, or you'd end up paying way too much for hardware. So especially as you think the costs are driven by, you want to spin up some virtual machines for data science or machine learning, AI workloads, these are expensive virtual machines. And so you don't want to be paying for, $1,000 a month machine when you only need $100 a month if you can make a few small changes to your code. So memory is definitely something to consider.
Yeah, and I think just in general, knowing different languages that work in different ways, it really expands how your mind thinks when you get to a new language. You're no longer just like learning the syntax, but you're more thinking, okay, there's got to be something equivalent to this other concept in this other language. How would I do it here? And you just end up learning it so much faster and having kind of a better overview of programming. So I certainly don't discourage people from learning Java and C++, even if machine learning is done in Python these days.
Also, though, if you're doing a boot camp, then you want that to focus on one language, because if you have multiple languages, then you're not going to have no time necessarily a 12-week boot camp to go deep. So things like boot camps, yes, you want to be functional in the language. You want to be able to pick up a language, run with it, build things with it, rather than the computer science fundamentals can come a lot later on. So Harry makes an interesting point. The only way to really understand what is happening with the hardware is to code an assembly. The learning curve is severe, and each CPU architecture has its own assembly.
That was my first programming class, was assembly. So I don't know if you're making a joke there, but if you are, like I'm kind of a living example of somebody who learned that way. Like it was really, the first class was like first exercise, implement the for loop with these instructions, and we need to like tell it to go jump to that number and then execute again and jump, right? But things like once you've learned it that way, then when I got to for loops, I'm like, oh, that's nice, and I could kind of appreciate them. It's like, oh, that's what they do. All these lines of code I wrote, now I just need one line, right? So I'm not necessarily suggesting that everybody start with assembly, because maybe it's a little bit too low level for these days. But I got to say that, starting from the basics does give you like a deeper understanding of everything you do as you go up the stack.
So Harry kind of continues actually to say, I wish software people learn more about architecture and design and not just fix exclusively on the code. It forces people to only think of optimizing at a fairly low level. Yeah, I mean, again, optimization is not just necessarily about the language you're using, but it's how you bring that together, how you architect a larger application, how you store data. And so you kind of need to have a bit of understanding about how a computer works, also up to how a cloud works, because you need to think about the architecture across the entire stack to make something more efficient, especially when we're looking at a time where, to quote our CEO, do more with less. And so if you can optimize what you're running on the cloud or on hardware, you can bring your cost down. So yes, there's a lot to be learned across the entire architecture of an application.
That's so true. I think I've been mentoring a CS graduate, and I'm actually really happy with the courses she's taking, and I think this kind of stuff is taught in college these days. So I think CS graduates these days will have those foundations of all the server, how servers work and how a computer works and that kind of stuff. It's been really refreshing to see how the kinds of classes she's taking and all that. But you're right, like people who learn programming outside of a CS degree, they may not necessarily have that, and they may also not have the motivation to to teach themselves those things, because why are they needed, right? They may not see the kind of the connection, the direct connection with what they're doing.
So Harry goes on to say, I coded in assembly for 3 years, changed how I coded forever. It's actually a hindrance for learning high level languages because they block you from seeing hardware activity. Yeah, I guess you've done assembly. I never got down that low level. I wrote one assembly program for my ZX Spectrum back when I was like 8 or 9 or something, just because someone said type in the numbers. But yeah, did you find it a hindrance? I guess actually Harry continues to say, I don't recommend starting with assembly. It's very difficult to learn. It would take too long to be practical.
Yeah, I mean, well, in my degree, we just had the first programming class just started with that. It wasn't the whole class on that, but it was just enough to give us an appreciation for the higher level languages, right? So I'm also not suggesting that everybody starts with assembly, but I do think that to a certain level, learning things first, in a way that is more basic, and then using and then learning the higher level languages, it does give you appreciation for what you get, and also an understanding of what's going on behind the scenes. And sometimes that understanding makes you do different things, makes you code in a different way. I don't think it was a hindrance in my case. I think it was kind of it gave me clarity in many ways as I was moving up the stack. And also happiness. Oh, now I can just do this with 2 lines of code, or it's so much easier in this language, or so yeah, that's how I feel.
Yeah. Probably useful for things like system programming as well. If you're building things in like Rust or C++, and just where you need to think about, I want to put this in a register because that way it's substantially faster because I'm calling it a billion times. It probably makes a lot of sense. Sense for that. But let's dive into some machine learning. That's what we're here for. Great conversation, great chat. Do we have those links, by the way, B? Because Cool Bros follows up to say, I was enabled with Python XE -m pip install. But yeah, we can get those blog links.
Yeah, I can put the blog link. So the one that talks about, I have one that talks about installing ZSH and doing this, configuring your terminal, which is this one. I don't know how to get, somebody will get it there, right? Okay.
Yeah,
and then I have another one that explains how to create your machine learning project, how to organize it, how to install your packages, or how to do your package management, and how to configure VS Code to use everything that you've set up in the other post. So those are two sides. It may be a little bit more information than what you're looking for, but that's kind of how I do my setup. If you want to do how people do their setup, people who are doing this every day, that's how I do my setup.
Cool. Awesome. Thank you for sharing. I think we've gone down a rabbit hole with assembly here. Harry's saying the only reason C was created to be a portable assembly. portable assembly, it was never meant for business software. Dariush says, I did coding in IBM OS 370 and 390 assembly for many years. You can guess I'm not very young. And Falcon Fire says, I did assembly. It was taught by the dean of the computer science department. He taught from the book. He wrote about it.
Nice.
So, okay,
Yeah.
feeling some assembly love. Maybe we need to do
Yeah.
a reactor stream on assembly. So there you go,
Yeah.
Pete, that's your next task. Teach assembly.
Totally. Yeah, probably not actually. Cool.
Okay, more questions. So we'll take this question. We'll start diving through the code in a second. But just want to jump on some of these questions here. So Colbros asked, for the Pumpkin CSV, the cleanup episode, can Power Query do the work when visualizing with Power BI? So I know obviously we'll be touching on this later in this episode, but if you watch the videos, we do a show on visualizing data, cleaning up and visualizing data. But Bea, have you used Power BI for doing any of this?
No, I have no idea about Power BI. Asking the wrong person.
Okay. I mean, Power BI is designed to be data visualization. It's dashboarding and that kind of thing. You put up the kind of thing we want to screen on a wall with a number of hits. But I guess if Power BI is not used for machine learning, then matplotlib's the way, is it?
Yeah, these days a lot of people use matplotlib. There are some alternatives that are popping up. Trying to remember. Seaborn is one of them. There's one, trying to remember the name. I can't remember. She's out of the University of Washington, actually. That is quite good. I'll see if I remember. So there are some alternatives, but matplotlib seems to be the one that a lot of people use these days. So that's the one we used here because we thought it's like the most popular and like where you should start. Yeah.
Cool. So another question. Marek G says, what do you think about IoT in combination with ML? Optimization of Wi-Fi, LTE networks, using artificial intelligence or game theory algorithms. I mean, I can take this one if you want, because I may dabble in IoT gadgets. I mean, I'm slacking today. I've only got one Raspberry Pi on my desk and nothing else. So that's slacking for me. Yeah. So AI is, well, machine learning in general, AI and all that kind of stuff. It is huge for IoT. When we think about kind of the first generation of IoT, it's about gathering data. And if you've got data, you need to make decisions on that data. That's the whole point of having data. And so the best way to make decisions is to use something like machine learning because it's the fastest way of finding patterns. I mean, sometimes you can just do a simple yes, no type thing. I've got a smart thermometer on my house, and if the temperature goes over a certain point, my aircon switches on. Well, it doesn't. As I was just explained to Bea earlier, my aircon's broken. But some IoT devices have that kind of very much on-off type scale. But it gets more effective if you can bring in machine learning. Can you look at the temperature in different parts of your house and use that with upcoming weather and calendar information to optimize how you heat and cool your house so that you're always warm or cool, but saving money? When you look at machinery, if you're monitoring vibration on a machine, what you want to do is you want to know what's going to happen with that machine. Is something going wrong with it? Can I detect it early? And can I do preemptive maintenance? You don't want to wait until your flux capacitor breaks down before you fix your machine. You want to know that, it should be vibrating like this. It's doing that. And that is an indication that the flux capacitor is about to break. So let's preemptively schedule someone to come and fix it. And you kind of build the whole automated cycle of, I'm picking up data from here. I know the signal means this. I will automatically book a repair engineer. No person needs to be involved. And so it's kind of just a huge thing people are doing for optimizing the use of the data. And then think about optimizing Wi-Fi, LTE networks. Yes, again, if you're thinking about a warehouse, could be 1 million sensors gathering data, and you've got to get that data from the sensors to the cloud in the most efficient way. So you can use machine learning to look at what is the data that I care about. How can I build an edge device that can actually decide on my data that works out what I want to do with it before I send it? Can I look at if I need long range communication? Is there an efficient way of using LTE or LoRa to get my data to the point as quick as possible? Almost like some of the original theory of the networks. If in the internet times where you're looking at the optimal route to pass network packets around, you can use ML to work out how the fastest way to get data from your device to the cloud if you're using things like slow connections. And there's just so many uses of machine learning when it comes to IoT, because machine learning, it's all about taking lots of data and making decisions. And IoT is the way of generating all the data. And I get really excited about this stuff because, you know, I geek out on it. But yes, yeah, your best friends if you're building IoT devices are a data scientist, AI engineer. Sorry, B.
Yeah, I actually have like an old AI show that iSkill and I did, where we interviewed this guy that did an artificial nose. That was he actually I don't know. I don't know how old it was, 13-year-old, 10-year-old, I don't know. And so I'm going to post the link because it's a really fun video. Yeah. So this kid essentially used, he had never done anything with AI before. He's not an AI expert. In fact, I think that he can't even code very well. Like he was still like just starting to learn. And he was able to kind of partner with somebody within Microsoft and create this artificial nose. And it's a really fun episode. So if you guys want to learn more about how to use AI to create, you know, with gadgets to create an artificial nose, then I recommend you go watch that.
Yeah, I'm gonna actually just share my screen. Yeah, so I love this story. I know a lot about this story. So it's a guy called Benjamin Carbe. He actually built this.
Yes.
Originally at Microsoft a while ago. And so he actually 3D printed a nose. It connects to a thing called a Weird Terminal from Seed Studio, uses volatile organic compound sensors and tiny machine learning. And yeah, it inspired a 13-year-old to go off and build something for detecting, was it detecting pneumonia or disease detection, wasn't it?
Yeah, it was a specific type of pneumonia that he, yeah,
it's absolutely brilliant, absolutely inspiring, and a lot of fun. And Benjamin does a lot of really cool videos and articles all about his artificial nose, and he's French and he really leans into it. So there'll be pictures of him in a beret and a striped shirt waving a baguette under the artificial nose and detects it's a baguette. So absolutely brilliant, absolutely brilliant.
Yeah.
So yes, IoT and AI. So actually, this whole thing that the Benjamin is doing is what's called TinyML. So the idea is you leverage the power of the cloud to train machine learning models, you big models, but the model you come out with is tiny, literally tiny, and they run on microcontrollers. So rather than having to have the big machine with the GPU running in the cloud, you have a microcontroller that's running at maybe megahertz instead of gigahertz. It's got kilobytes of RAM. Not quite coding in assembly. Just tying it back to the questions earlier, but you literally can take like a 20 kilobyte AI model and then run that on a device. So the models that you build are tiny. They're not as necessarily as powerful as that you'd run on a big GPU, but the whole goal is you're running it on a low powered device. So you kind of get that instant decision. You don't have to be connected. You don't have to worry about streaming data to the cloud. It's just that instant decision. Yes, no, this is a baguette. This is an onion. I think originally started off doing it using whiskey, vodka, and other spirits. But yeah, it's definitely a rising area in machine learning at the moment. It's this idea of you train it and it runs on some form of teeny tiny device. So TinyML is kind of big right now.
I'd like to call out a couple of things that are coming up in the chat. So one, Kevin mentioned Plotly. Plotly is also a really nice visualization framework, maybe my favorite. It's not as popular as matplotlib, so that's not what we're teaching this course, but it's really fabulous. I do recommend it. Yeah, that one.
This one.
Yeah, I really like it. Yeah. Yeah. When I'm not teaching, that's probably the one that I would be using myself. But when I'm teaching, then I prefer to use matplotlib or even seaborn because they're more widely used at this point. And so I think that people should first understand the thing that most people use and then kind of go and decide what works for them after that. And then the other question is like, what is a widely respected certificate I can take on ML as a beginner to ML, but with significant programming experience? So what I would, I don't know. Yeah, exactly. I don't know if I can highlight it. Okay. So what I would recommend is a shift of thinking. If your goal is to get a job in ML, I would worry less about having something on my resume, unless it's like a master's or PhD from a well-credited university. I think that counts. But I would worry less about having a certificate on your resume and more about having projects in your, that you can showcase in your resume, like a link to a really nice GitHub with lots of really cool projects. And we've talked a little bit about that last week. And I will repeat it because I feel strongly about it. Like if I'm a hiring manager and I'm looking for somebody in ML from my team and they say they have some certification, I'll be like, whatever, like, unless you have a PhD from somewhere, PhD, I may think, okay, he's done research. There's a bunch of assumptions that comes like he's done research, he knows this area really well. Maybe he would be good to kind of take over that area or to take over connections with the university or with Microsoft Research. Then there's all that thinking. But if you don't have that, a certificate is not going to impress me as much as a really cool GitHub with really cool projects. And how do you get the ideas for those projects? Do certificate or do courses, whether they give you a certification or not. Just do machine learning courses, because as you're working through the exercises, you're going to get ideas for your own projects. And so go do them and write a really nice README and come up with a really nice portfolio, put that in your resume and start applying for jobs.
Cool, great thing to share. I'm just thinking about like the Microsoft certifications. They're very much about using the Microsoft tools. You get a certification using Azure ML. It doesn't actually say that you know anything about machine learning itself. It just shows that you know how to use the tools. So maybe a useful addition if you are applying to a Microsoft shop. You're applying to a company that uses Microsoft products. Could be a useful addition to say, I know the tools, but it's not that I know about machine learning.
Absolutely. In fact, I would say a lot of people who work with Azure at a higher level don't know machine learning. And I'm not saying this in a bad way. Like they're very useful and they can do a lot of things that people who know machine learning can. So it's a very useful skill to have, but it's not the same skill, right? They're different skills. So I agree with that. If you're going for a particular Microsoft project, yeah, look for certifications. But if you're really learning ML from the beginning, I don't know of a good certification that at least that I would get impressed with if I saw in a resume. Yeah.
So just think about the whole Azure ML thing here. Mark asks, still get up to speed on Hugging Face for NLP and Hugging Face's integrations with Azure. Interest in training a small LLM. Any recommendations on exploring this for the 30-day
small LLM? Small LLM is kind of like LLM is a large language model, so you can't have a small, large. Right? You can have a small language model. You can have a large language model.
It's like having a small planet, isn't it?
Yeah, exactly.
But yeah, any recommendations for exploring this through the 30-day free Azure trial?
Yeah. Yeah, for sure.
Also learn about the sandbox, advice on the best approach to self-learning through these services. I mean, the sandbox is just for learn modules, isn't it? So it's just for when you're following a set of steps.
Yeah, exactly. Yeah, and Azure does give you, I believe, I don't know, $150 for free or so. And so I do think it's worth taking that offer, and using that money, that Azure money, towards learning and towards evaluating the platform. And I think that the 30 days, is it 30 days? I think it's different for students, right? Students is like.
If you're not a student, it's $200 and it only lasts 30 days. If you are a student, then you get $100 that lasts you a year, and that renews every year you're a student.
Yeah, that's it. Okay, so that's it. So yeah, I do recommend you use that money, and maybe follow some tutorial or something like that as using that money to experiment with it. So there was a thing that just happened called the 30 days of AI, AI April. That's what it was. Yeah, I think it was AI April. See if you can find it. Yeah, exactly. Or 30 days of AI. Yeah, that thing. That does. Yeah, which does give you like a good like structure of like what are the things that you might want to learn within Azure AI. And like gives you like a nice sequence to learn those things and points you to resources to learn that. And so that's one great way to use that money, to use that free money, to just go through here and work through some of the problems, work through some of the tutorials, and sign up for the free subscription.
And another comment here from Nazifa, which I think you ties back to something you were talking about last week.
Yeah,
you can always use Kaggle to do projects on challenges.
For sure. Kaggle is fabulous. Yeah, Kaggle is fabulous, and there's plenty of stories of hiring managers actually just going and looking who are the best Kaggle people, and then just giving them job offers just based on what they're doing on Kaggle. So it's a great way to get visibility for potential jobs also.
Cool. Harry makes a joke that I don't get, but I'm guessing you probably would get this. How do you explain LSTM models if you can't have opposite concepts in ML? I'm guessing this is about a small large language model.
So LSTM is, that's what it stands for. Long short-term memory. That's a good point. That's a good point. It is kind of a funny name. Yeah, if you can have opposite concepts, yeah. I mean, they, they are what they are, and then they named them what they named them, right? Like, do I think they're long or short? The goal with LSTMs was to fix some of the issues that RNNs had, where you couldn't like pass weights when the RNN got too long, because they would either, you had like vanishing gradients or exploding gradients. So the weights would just like either go to 0 or to infinity as you kept making the network larger and larger. And so LSTMs came up with some techniques to prevent that. Why are they called long short-term memory? I don't know. I don't know. Sometimes the names are, they are what they are.
Yeah. So you can have small large language models that make the long short-term memory and the small large language model. It's a thing. Cool. Should we do some code?
Let's do some code.
I think we got through some of the questions so far. Yeah, let's do some code. So the whole point of today is obviously, number one, answer your questions. We're back in tomorrow to answer questions, but it's, we are here to help you. The whole point is we drop the videos on Monday. Let me put a link in the chat to the videos if you haven't seen these yet. If I could type, I cannot type today. Emma. So we dropped some videos on Monday that kind of walk through some content from our Machine Learning for Beginners curricula. I'll put both the links in the chat in there. But the idea is, so we dropped some videos on Monday that went through linear regression, which is all part of our Machine Learning for Beginners curriculum. So this is our curriculum. I dropped a link in the chat to that, where it's 26 lessons to teach machine learning from the basics. We really start with the fundamental principles. I mean, I'm able to follow along, and I don't know anything about machine learning, so it's been pretty good. And yeah, so Monday we dropped some videos. Hopefully you watch those. But today we're going to just dive into a little bit of code and kind of talk about it a little bit more. And we're going to do this using GitHub codespaces. Rather than set up my local environment, I'm going to spin up a code space because it's easier. If you've not come across codespaces, they are basically free computers in the cloud that you can connect to. Well, not free for 60 hours, but they're computers in the cloud that you can connect to that are pre-configured with a coding environment running VS Code over the internet. You get 60 hours a month for free, and then you can pay for more than that, or if you want more powerful machines, you can pay extra for more powerful machines. So I like them because 60 hours a month is usually more than enough for me dabbling with things. And they sometimes have great names, because my current code space is called Crispy Space Doodle. And I don't... Sorry, first of all, that's really tickled me. Crispy Space Doodle. So what we've got configured in our curriculum is we've actually got the code space configured. So when you launch it, it's got all the tools installed. It's got Python installed. It's got Python extensions, Jupyter notebooks. So I literally just click go. We configured it in the repo. And then you'll see right now we're spinning up a little bit. We're spinning up Visual Studio Code running through the cloud. And this is a full VS Code. This is not the github.dev where you can just edit files. Yeah, I've got a... If I press the right button, come on. There should be a full terminal. Where's my terminal gone? There's my terminal. So I've got full terminal, I can run things. We can run Python. It's there, it's running. So it's a full development environment. Kevin Chung says, love code spaces. Please keep the 60 hours free forever. It makes these reactor sessions lit. Thank you.
That is so true. Yeah, I was really happy when they announced the 60 hours, because I really think that it makes the essentially codespaces work, right, for most people. Yeah.
Yeah, if you're playing around with it at home, it's great. It's kind of enough for what you're dabbling at home, and then ideally at work, your company would pay for it. Just the whole fact that projects are pre-configured. Yeah, this is running. It's running on Linux. It's running Python 3.11.3. It's all configured by a file here that says we want a Python 3 container. We can install various settings for linting. Visual Studio Code extensions are pre-installed. All that kind of stuff is just done. It just works. You know, one click, and I've got a full environment that works. If you want to run locally, we do have a video on setting up your tools that talks to the tools that you need. But we're running this all in the code. I'm running this in the code space because it's needed. Harry says they needed something to compete with Google Colab. I'm already up on Google Colab. Bea, you're the expert, aren't you?
I love Google Colab. I have to say, it's really good for collaboration, as the name says. And Harry's right. We, you know, it's a really great tool that you know. I'm not sure that we have like a completely parallel alternative. We have several kind of things, and I think that codespaces is also kind of offering some of the features that Google Colab has, but you're right. And also Google Colab has a huge community also, right? Like, because it's a lot what people use in universities. It's what's often the environment that students use. So there's a lot going for that. Somebody else saying Colab is great. Yeah, so it's essentially a notebook environment on the web where you can collaborate with other people. And it's really easy to collaborate, and it's really easy to set it up and everything. And so I think it's a really great offer that Google has.
But it's just notebooks.
It's notebooks,
right?
Yeah.
Right. Yeah. Whereas Codespaces, it's a full coding environment. So yeah, you want to use Rust or Java or web dev, do web dev, whatever. You've kind of got everything. And you can run Jupyter notebooks in it. So it's kind of because Colab is free for how many hours, isn't it? It's free forever. Is that right?
So I've used it a lot in school, and I never hit that limit.
Nice.
So yeah.
So
I don't know what the limit is.
Cool toys for everyone.
Yeah.
Codespace is 60 hours and does everything.
Yeah.
Colab is kind of forever, but just does notebooks. So Colab is to Jupyter Netbooks. I can't English today. Colab is to Jupyter Notebooks as Google Sheets is to Excel.
Yeah.
It's kind of like a hosted version of it.
Yeah.
Nice. But you can also run notebooks in Codespaces. You know, just getting on the Microsoft bandwagon a bit. We do work for Microsoft after all.
And also, like, notebooks are great, and we're going to be using notebooks in this thing because they're really nice to teach. But you'll find that a lot of people in the industry, at some point in that kind of a flow of like from experimentation to deployment, there's going to be at some point there, maybe at the ML engineer point or so, that a lot of that code in codebooks then gets converted into Python files to be able to run in the cloud and to kind of be kind of more kind of refactored and self-contained and all that. So this is kind of a common practice as you if you kind of there for the full life cycle. So I like that if VS Code has that ability, right? That it's actually quite easy. I think there's even a button where you can have a node space and you can just say convert to PY to a PY file, and it just does it for you. So like it's certainly. Like if you're thinking more like longer term production and not just experimentation and learning, there's a lot of features in VS Code that are going to take you further, I would say, than Google Colab.
Cool. Okay, so let's actually fire up a notebook. The whole point of the series of videos we're working through is to actually get going with a notebook. So I'm actually going to bring up the code as well, the instructions. So we are working through regression. And Harry made an interesting point about regression to say regression isn't about regression at all. It's named that because the techniques showed height regression in humans, but math and ML people still use the wrong name for it.
Yeah, when it sticks, it sticks.
And Ravi says, I agree with you on regression. I was very confused about that word as it is applied to maths. So yeah, So what is regression then? What is regression? When we talk about regression, linear regression, what exactly is it?
So in the videos here, we talk about 3 different types of regression, which is linear, polynomial, and logistic. And polynomial is really just like a subset of linear. So we can really think of just like linear and logistic, really. And so what it does is, if you have a set of data points that you've collected, regression finds a mathematical formula that best represents or best approximates those data points. I wonder if we can get an image like in the video. In the video, we had a really nice image. Yeah, like that, exactly. So for example, if those little orange, let's say in linear regression, if we have those little orange points, and those are like just the data that we collected, and then we want to make a prediction using that data, what we do is we first find a line that best fits that data, like which is represented by some mathematical formula. And then once we have that, then we can make predictions based on that line. So if you have a particular X value that you measure in the future, you just see what the corresponding value is on that line in Y, and then that's your prediction. So it's not going to give you exactly the same values that you saw during training, because obviously the line doesn't go through every point, right? It's just more like approximating it, but it like reflects the kind of the general trend of the points. And so that's with linear regression. Polynomial regression is basically, as I said, just a subset, or like a special case of linear regression, where instead of having a line, you can have more like any shape, basically a curve, or something wavy like here, like what's shown here. So you can have a more complicated function that could have squares and cubes, and it could have sines and cosines and logs. It could have anything, whatever you need to create a mathematical formula that represents the points that you have. So that's basically what it is.
And I guess you don't want it to go through every single point, because if you do, when you do new points, they may be wrong.
Yeah,
Isn't that
because it
overfits
overfits.
or something? Yeah.
That's overfitting. Yeah. So you're right. Like if you do go over every point, then you're no longer like representing the general trend of the data. You're like representing that exact data. And so you're actually going to start getting worse predictions that way if you overfit too much to that data. So it will do better if you try to make a prediction on your training data. But if you make a prediction using data that the model hasn't seen during training, like your test data, then it will actually do worse. Like it'll make worse predictions. So we do need to watch for overfitting in our data. That's
I guess it's kind of like if you had to write code to divide a number by 3, and you're given 3 test cases of 9, 12, and 27, you could write code that says, if my input is 9, return 3, if it's 12, return 4, if it's 27, return 9, which would give you the right numbers. But as soon as you put a different number in, it would fail. Whereas if you just return divide by 3, you get the right answer for new input. So you need to make sure that your line shows a trend, so that as you do new things, they map to that trend. Is that basically right?
Yeah, that is correct. Yeah.
And
it's a trend. Yeah.
It's about a trend, isn't it? It's not about
it's about a trend.
Yeah, you're not being exactly right. You are
right.
It's about a trend. Yeah, I agree with you, Falcon. That was a really great explanation, Bea. Thank you.
Oh, good. Thank you, Falcon. Yeah, I mean, the videos actually are a little bit better than what I just said, because they go a little bit more into, I guess they're more succinct, and they're short, and they deliver the message. Like, yeah, succinct.
Good stuff. So yeah, so the whole point of this then is we want to find a general trend in our data, so that when we can use that to make guesses against other data that are not going to be 100% correct, but they're going to be in that right kind of area.
So I get a question often when I'm teaching this to people, which is like, it's all deep learning these days. Why does this matter for, I want to learn deep learning. Why am I learning this? Why does it matter for deep learning? And the interesting thing is that you can see deep learning as a kind of like a generalization of regression. So as I was saying, in polynomial regression, you can have many more, like your formula, right, that represents that line could be y equals to b plus mx1 plus mx2 plus m times x1 times x2 and plus log of m plus whatever. Like you can log of x. Like you can just like keep adding. If you have lots and lots of features in your data, you can just keep adding and adding to that formula. But it's not very effective, right? Like then you have like this unreadable formula just because you have all these features that you need. And maybe you have X and you have Z and you have W, you know, you have other features coming in, other things that you measure that affect the thing you want to predict. So like what deep learning is, or neural networks are really just like a much better way of dealing with lots and lots and lots of features. And so it's almost like a generalization of regression, or a better way of doing regression when you have lots and lots of features. But the idea is the same. You're still trying to fit some mathematical expression to some data, basically. So the ideas are the same. And then the other main difference is that if you actually have not a lot of data, if you just want to fit a line to not a lot of data, then regression might actually, it does fine. Like you don't need, you know, you could certainly use deep learning, it would also work, but regression does great and it's simpler, so use that, right? And the reality is, when I talk to customers, that a lot of people, not everybody is working with the amount of data that OpenAI is working with. A lot of real world problems, people actually don't have that much data. They just have, you know, a couple thousand or 10,000 or whatever. And for those numbers of data points, regression is actually fine. Like, and you shouldn't use like a bigger tool if you don't need it, right? But deep learning does really well, much, much better than regression, with tons and tons of data. When you start getting to, you know, 1 million data points, 1 billion data points, then deep learning is going to do better. And so then that's when we would kind of move that. But I do think it's important to understand this, so that then you can understand how it generalizes. When you look at deep learning, then it's a lot easier to understand, because you're like, oh, okay, yeah, it's similar idea, more features.
But also just think about speed here, and actually running the thing. Deep learning, you need the neural network, don't you? Once it's all built, you're going to have to store, you know, think about OpenAI, you know, gigabytes of neural network where you put data in and things come out the other side. Whereas linear regression, it's just y equals b plus mx. So
Super
once
simple.
you know b and m, if linear regression is good enough for what you need to do, it's quick. I mean, doing that math is so quick. You're doing one multiplication and one addition, that gives you an answer, and then you can just decide whether that's the answer fits within what you want or not. Whereas, you say deep learning, that's big. That is, you can't run that on a small artificial nose. Just thinking about going back to the project you were talking about before, whereas linear regression can run anywhere. You can do it pencil and paper if you wanted to.
And you could also do a small neural network, right? So like when I say deep learning, I don't necessarily just mean like OpenAI or like these large models. You could also create one simple neural network yourself and run it on your machine and make it fast and small. But where it shines is really in the kinds of models that you're seeing OpenAI do. They use deep learning, and they couldn't do what they're doing with regression, that's for sure. But not everybody needs what OpenAI needs. So I think a lot of the kind of skill of a data scientist is also like picking the right model for the right problem, and not use a bigger hammer when the hammer isn't needed, right?
Yeah. So Jim M asks, regression does not find exactly the same, but does find what rhymes. And
Nice.
this is samples from a population which may be subject to some kind of noise.
That's very true. There are ways to kind of deal with like how you handle noise, generally in the loss function. It's a little bit more advanced than maybe what we want to go here, but like there are ways in the loss function where you can be more susceptible to noise or more robust to noise. I don't want to get into that. It's more complicated math, but feel free to reach out to me offline and I'm happy to explain that to you. Anyway, so like in the way that I believe that what we use in the course is just least squares, which is like how you measure the accuracy of the quality of your result. But there's other measures that are more or less susceptible to noise. I'll just put it that way.
Isn't there some cleaning you can do where if something is way out? So if you had a point, I just zoom in on here, for example, if we had a point right up here, we would actually cut that out from the data set. So maybe look at the distance between points, and if you've got one point that's a long way away from the others, you kind of just cut that out and just say we don't care about that.
Yeah, you can do that in data cleaning. I think you do need to like be careful with that, right? Because you know, it could be noise, but it could be real. So, you know, you don't want to just delete points just because the answer isn't what you like, or somebody gave, you know, you got some survey out and somebody gave you an answer that is not quite what you want. But so I think that it requires a lot of care, like when you start removing points. But I think it is sometimes appropriate to, when you just have, okay, this person just like didn't even read the question in the survey and they just answered something or whatever, you know. So there's that. Yeah.
So Falcon Fire says variance would get rid of outliers.
What do you mean exactly? Variance is more of a measure of like how the distribution, like how spread out it is. So it doesn't actually change distribution. It's just more like a measure that tells you. You could say that you get the variance, and then if you see things are like totally outside of like a 90% thing in the middle, you remove them. So, but that would be like what Tim was saying. You would clear the outliers. Yeah, so you could do that, like clear outliers if that's an issue. Also, Vivia is saying, is medium level Python knowledge enough to start machine learning? Should I need to learn something else too before starting ML? I would say that that's the biggest requirement. You know, if you were in college, and then maybe college students here, I mentioned this also in a previous choice, there's college students here. I would say if you're in college, make sure that you take a statistics class, linear algebra class, and a calculus class. So that would be like the right math, or all the math basically that you need. Maybe optimization, but you know, that's maybe not. I don't know. The first three are like the essential. But I definitely think it's possible to learn just the little bits of math that you need to understand this as you go. So for example, as we're talking about regression today, you're already dealing with math here, right? You're dealing with a formula, a y equals to, you know, x1 plus x2, whatever formula that gets drawn on a map that may kind of reflect the trend of some points. This is already math, right? So I think that if you can pick up as you go like this, then it's great. If you get to a point where it's like, oh, you just lost me there with the math, then I would say take a break, go learn that concept somewhere else, you know, take an online class or whatever, just for that little bit, or an online video, and then come back. But I don't think I wouldn't recommend, like, for somebody in the industry to just go take calculus and algebra, unless, you know, you really get stuck a lot or you want to go really, really deep in the details, sure. But generally, if you just want to accomplish the basics, I think you may be able to pick up most of it from watching the videos and reading the readmes here in the repo.
So we're actually going to just dive into some code. I thought it'd be a good example to actually dive into some code.
I love that.
For the diabetes data to actually do some regression. So I'm just trying to find the I'm just going to need to make sure I install the libraries.
Yeah, there's basically like two lines of code that are really important to what we just saw, which is a line of code that fits, like it's a line of code that says .fit, which kind of essentially gives you the line that best fits the points, basically. And then a line that does predict, which is a line of code that gives you a prediction. And once you have an X, it gives you a prediction on that line. And so it's
that's
really
actually walk through the code. Yvette says the video looks fuzzy, so I'm just going to make it a bit bigger.
Okay.
It's so, I mean, this is the code we've got here. So we start off by importing some libraries, just bring in some libraries. This particular example is a diabetes data set. So this is some data that looks at a number of medical data points with progression of type 2 diabetes. And so, I mean, the code here, we load our data set.
Yep.
And that's just printing out the shape of it so we can see what kind of shape it is. We then need to work out what it is we want out of our data set. So yeah, this is not just going back to Vivia, your question about Python. You know, we call a load function, get a tuple back. So we're using the code that's there. And we want to get the third feature. So in the data set we've got, if I try and find the actual, where's the link to the data set?
BMI, I believe. No, this is, yeah.
I see that data set was actually here. Okay, but basically the features we want, so it's based on BMI, which we all know is a terrible measure in general, but there is a relationship between body size and type 2 diabetes. So, you know, we want to get that BMI feature. So we just pull out a feature. It's using NumPy arrays. So again, it's not hugely complicated. Bit of shaping. So this is kind of data science. So we're just rejigging the size of things a little bit. But really the linear regression part, and I'm diving in and saying this because I actually understand this code. You know, I understand it, and I'm not a machine learning person. So step one is we split the data. So with X and Y, so X is the inputs, Y is the output. So we think back to the picture we talked about, where you had, where are we? Where's the actual picture? Where we had Y equals MX plus C or whatever variant of letters. Wrong one. If I go, is it this one? Yeah. So we have this straight line here. Y equals B plus MX. We need that. We need our Y's. We need our X's that feed in to the model. And so we split our data. The idea of splitting it is you want to use most of the data to train the model and then some to test it. You don't chuck all your data in because then you don't know whether it works or not. You've got to have a test set. You've got to be able to verify that it works. So you say, split my data. It's a fairly standard thing that machine learning folks do. They split it. We want our test size. This is 1/3. So 2/3 to train the model, 1/3 to test it. Then we create the linear regression model, and then we just call fit. So, you know, it's not huge quantities of Python. Yes, it helps to understand what a tuple is for some of the inputs and outputs, but really we call fit and the magic happens. And that's it. We've got a model. We've trained our model with our X trained data and our Y trained data. So this has taken all the X points, the BMI measurements, all the output points, the progression of diabetes, and worked out a line. And then once we've got that, we can then, if I click the right button to run the right one, we can then call predict, which will just go through and actually take our test data and look at the results. And then we're using matplotlib to plot it. So it's not complicated code. We're not digging down deep inside Python code. We're not doing really weird things and having to understand the language. We're almost writing this in readable English in some ways. You know, fit the data. That's what it's called. It's fitting. You fit the model. You then run predictions. And then we say we want a scatter plot, draw the plot and show the plot. And bang, there is our linear regression line. And this has taken all these data points and worked out what the right gradient and intersect point is for the line. So it's not complicated Python code. I kind of understand roughly what this is doing. In some of the later episodes, it gets a bit more confusing. It uses libraries, but that's all about reading up on the library, isn't it, really?
Yeah, and I think there's in those 3 lines of code that are really essential. I'd say the 3 lines of code that are essential are the train, test, split, the fit, and the predict. You know, you'll see that those 3 concepts show up even if you go to very advanced models. If you're even OpenAI writing their own models, they'll typically do some kind of train, test, split because they need the train and the test data. They will do some sort of training of the model, which, you know, in this case we call fit. You know, it's different function with different models, but there's some concept of training the model using the data. And then there's some concept of making a prediction on the model, essentially giving it some data and getting a prediction back. So those 3 things are just very simple. Here, of course, they get very complicated once you have like more advanced techniques, but the ideas are the same. And so they're important to understand like now, because you'll be seeing them later again.
And it's not like you have to understand how they work under the hood, really. It's if you know what you're doing, you've decided I'm going to try linear regression. And if you work through the repo, we'll probably dive some more on this tomorrow, and you look through the videos, we're looking at making predictions about pumpkins. We try one, train, test, split, fit, predict. Is it good? Maybe not. Let's try another thing. Train, test, split, fit, predict. You kind of just keep iterating on that cycle. I guess we can dive into that a bit more tomorrow because we are practically out of time. We are out of time. We're only here for the hour. We are back tomorrow, same time. Make sure you sign up. We'll get a link dropped in the chat if you haven't signed up to the series. But yeah, come join us tomorrow. We will probably carry on working through a bit more of this. The whole point of tomorrow was originally around questions, but we had so many questions today. Tomorrow we'll spend time doing questions and we'll dive some more into this code. And then we have more videos dropping on Monday, and this kind of carries on next week and the week after. So just had a link dropped in the chat if you to sign up for the series if you haven't signed up already, and that will make sure you get all the calendar reminders. We dropped a thing in the chat for our survey as well. Please, if you could fill in the survey. This is a new experiment for us, the idea of recording some videos based off content we've got and then dropping them and then running these live sessions to kind of help work through those and answer your questions. So we want to know whether this is working for you or not, how we can improve it, what works better, what's not, because we want to make sure that the shows we put on for you are the best thing that we can do for you. So please fill in the survey to let us know what we can improve. But otherwise, thank you, Bea, for joining. Thank you, everyone who joined in the chat. Great conversations about everything from linear regression to assembly language programming. So
yeah,
thank you, everyone. And
Thank
we'll see you all tomorrow.
Yeah.
Take care.
Awesome.